Let's recap. What did I say were enzymes?
Well, enzymes are used to speed up a chemical reaction.
Yes.
They are proteins.
They are proteins. And because they are used to speed up the chemical reactions, we call them biological catalysts. Very good. What about the enzyme vocabulary that we spoke about in class? What was the substrate? What do we call the substrate?
I think in subject is what will be used whenever you're testing.
Well, I'll accept that. So we say the substrate is the reactant or that thing that the enzyme is going to work on, right? So what is the name of this part of the enzyme where the substrate will bind?
Active site.
The active site. Very good. All right. So remember, to get the substrates into its product, they speed up the chemical reaction by lowering what?
Activation.
The activation energy. And what is the activation energy?
Energy is the energy needed to start the reaction.
Wonderful. It's the energy, she said, is the energy needed to start the reaction. Wonderful. Or the energy needed to form or break the chemical bonds and convert the reactants in their products. We spoke about two theories associated with the enzyme substrate complex, right? What are the two theories that we spoke about?
Lock and key and induced fit.
Beautiful. Lock and key and induced fit. So let's talk a little bit more about the lock and key. What did I say was the lock and what did I say was the key? Was it the substrate or the enzyme?
It's the enzyme in the lock.
Beautiful. The enzyme is the lock.
And the substrate is the key.
And the substrate is the key. Beautiful. So in the induced fit model, we have the substrate here and the enzyme here. But if you can see, the substrate has a slightly different shape from the enzyme's active site shape. Upon the binding of the substrate to the active site, it's gonna induce a conformational change or prompt a conformational change in the enzyme's active site. That's why we call it the induced fit, after the active site has been induced, right? And this is the more accepted theory. All right, let's talk about some of the factors that affect enzymatic activity. We spoke about 4, right? Substrate concentration, enzyme concentration. What are the other 2?
Temperature and pH.
Temperature and pH. Very good. Guys, remember the optimum temperature and the optimum pH for most of the enzymes to function best in our body.
36 or 37.
Very good. 36 or 37 degrees Celsius. Outside of that normal temperature range, then the proteins in the enzymes are going to denature, right? Or change their shape. They won't be complementary to the substrate anymore. What about pH? So remember, in macromolecules, we spoke about proteins, that the amino acids were the building blocks of proteins, right? So remember that part on the amino acid called the R group, it's pH sensitive. Can you guys remind me of any enzymes that function best in an acidic environment?
No, pepsin, yes. Well, yeah, with the hydrochloric acid in the stomach.
Yeah. So pepsin is a very good example. Pepsin function best is about 1 because it is in the vicinity of the hydrochloric acid, which is a strong acid. And then what about basic enzymes in the digestive system?
Amylase.
Very good. Amylase, as you said, salivary amylase, it functions best at a basic pH. For example, in the mouth, along with the factors that affect the enzymatic activity. We spoke about activators and inhibitors, right? Activators being the cofactors and the coenzymes, and inhibitors being competitive versus non-competitive inhibitors. So in your own words, what are competitive inhibitors and what are non-competitive inhibitors?
I would say the competitive inhibitors, they interfere with the substrate binding with the enzyme.
Yeah, how? Competitive. Remember, this competitive inhibitor will have a structural similarity to the substrate, right? So it's going to compete with the substrate for what? The active site, right? That's why we say it's a competitive inhibitor. What about non-competitive? It's not going to compete with the substrate for the active site. It's going to rather bind to another region on the enzyme. We call it the allosteric site, right? And guess what? The substrate will no longer fit into the enzyme, right? It will no longer become complementary to the enzyme because of the presence of this non-competitive inhibitor. And those are some of the important points to remember in the structure and functions of enzymes, all right? Okay, how do we feel about this concept? What were the drawbacks to this to learn about?
It's so far.
It's good so far. Did you have some challenges mastering this concept?
No, it's not understand now.
We're clear, so we're ready to move on to nucleic acids. Are we ready?
Yes.
Wonderful, wonderful. That's what we're going to be talking about today. Nucleic acids.